Welcome viewers in our Learning for Knowledge YouTube channel, and in this video, which is the series of the videos related with the boiler, so we want to describe you some of the issues which have occurred due to the water quality used as a boiler feed water in the steam boilers. These issues are scale, corrosion and carryover. We have to control these issues to avoid any problem occur during the operation. It will lead to a catastrophic damage in the boiler or in the steam turbine. So we will describe these things, and some of the root cause of these issues will also be described in this video. So we will move towards the video. You know that the quality of water used in the boiler plays an important role. And if we use a low quality of water and that water is without any treatment, this may lead to the damage of the boiler tubes, and this will stop the operation, and there are huge losses occur due to this low quality water. Now the chemistry of water has direct effect on the following problems, which are scaling, corrosion and carryover. These type of problems occur if the quality of water is not good, or during operation we will not properly address these issues. So these problems arises basically due to different types of contaminants present in the water, and during the stage of water treatment some of them will be removed. If they are not properly removed, then these cause a problem of scaling, corrosion or carryover. So as you know, what is scale? Scale is formed due to deposition of calcium and magnesium salts at high temperature into products like carbonates, hydroxide, sulfate. So when calcium and magnesium form these compounds of carbonate, like calcium carbonate, calcium sulfate or magnesium silicates, they are settled at high temperature in the boiler. So this is called scaling. Second very important is corrosion. Corrosion takes place due to the presence of dissolved gases like oxygen in feed water or carbon dioxide, which is produced during the decomposition process of carbonates and bicarbonate. This carbon dioxide is present in the water circuit and cause some problem of corrosion. So scaling, basically, what is scaling or deposition problem? Scaling or deposition occurred due to the precipitation of minerals dissolved in the feed water, causing the formation of one or more types of scale on boiler system components. As we described in the last page, that these are basically the salts of calcium and magnesium carbonate, sulfates or silicates. They normally settle down and precipitate when temperature rises, and these are settled or precipitate on the piping, in the steam drum or other circuits of the boiler. So this deposition basically this deposition leads to the scaling. Now this deposition can also occur when there is a corrosion is occurring, and the corrosion products which are rust enter in the boiler after they are created, and these corrosion products can form iron based scale. Or there is another problem, because during the operation we apply water treatment chemicals for control of scaling or other corrosion, to reduce the corrosion. But if that treatment is not properly applied, then this results in the scaling. Normally in some boilers, for example, they use phosphates compound. If that is not applied in proper way, or the concentration of phosphate increase, this leads to the settlement or precipitation of calcium or magnesium phosphates on the surfaces of the pipes and other places in the boiler. So scale can occur in any part, any section of the boiler, and the result of this precipitation or deposition is it reduces the capacity of heat transfer, that is, heat transfer from heat source to water through these metal pipes. Due to scaling, this reduced, and due to reduced heat transfer, the metal tubes operate at high temperature, because the scaling is based because the scaling is occurred on the water side and the heat transfer is reduced, so there is a less cooling or less heat take away from the furnace to the water. So basically higher reduced temperature becomes higher, and consequently steam is produced inefficiently because less heat is transferred from fuel to water, and this decrease the production of steam, or you can say the reduction in the temperature. So less steam is produced, and for the production of that the specific amount of steam we need more fuel, and that fuel costs are increased. So that's why this is very important to look in this scaling, because in this video we are just describing the basics. Maybe in later on we will describe each of these problems separately. So this is, you can see in this diagram, there a huge scale took place inside the tubes, and here you can see this is the scaling and this is the pipe. This is the pipe. So this layer of scale reduce the heat transfer, and ultimately this will damage this pipes, and there is a big problem in the operation of this boiler. So greater the thickness of the scale, the greater the insulating effect, that is less heat transfer took place, and the higher the temperature of the tube. And when the less heat transfer takes place, the temperature of the tube increases. At sufficiently high metal temperature, the tube can lose its strength and rupture. This is a big problem. This is a typical diagram which shows the effect of thickness, deposit thickness on the tube metal temperature increase. Here in this case 4 type of different materials have been explained. Here this is if we plot the deposit thickness against the temperature, then you can see that anal side, which is sodium aluminium silicate, this line shows that as the thickness increases, the tube metal temperature also increases linearly. You can see that in magnesium phosphate, this is second line, then magnetic iron oxide, which this is due to the Corrosion product, here this is the line, and calcium phosphate or hydroxyapatite. So you can see these, except this magnetic iron oxide, if a slight scaling occur, it will start increasing the temperature. So you can see, if you look, that this is the 0.05 mm thickness, and if it will become double, then you can see the temperature, which is around, you can say 15 degrees centigrade, is now reached to 35. So as this thickness increases, the temperature of the metal surface also increases. So it is very important and critical to control the scaling to avoid any of the problem. So if we summarize all this, then troubles in the operation due to scaling, the reduction of boiler efficiency, this will reduce the boiler efficiency, because and damaging of operation tube, these tubes will start damaging as the metal temperature increases due to less heat transfer. And what are the reasons for these? The presence of hardness and silica in feedwater due to problem in demineralization process or application of inadequate chemical water treatment. These are the major 2 reasons which leads to this problem. Next is the corrosion problem. Corrosion problem are due to action of dissolved oxygen in the boiler, that is the dissolved oxygen which is present in the boiler water, it will start corroding the system. The effect of low or high pH on metal components, because the variation in pH it affects the components of the metal, including the boiler tubes and drum, which are constructed of carbon steel. So we have to operate the water in a specific range of pH where there is a minimum corrosion take place. Corrosion can result in loss of metal, that is metal will be lost at some places. This is also corrosion, and occur due to alkalinity of excessive pH of the boiler. If the pH is continuously exceeding from the limit, then due to that alkalinity, which is due to hydroxide, it will start corroding the system. So corrosion is also a safety concern, very important. So we have to look and keen towards the corrosion phenomena. Corrosion in the steam lines, condensate line, and in the carbon steel piping can result in leaks leading to loss of condensate, a situation which increases demand for energy, water, and chemicals, and outage of the plant as well. So if we summarize this, troubles in operation due to corrosion, which is basically damaging of pipes of feedwater, condensate, and evaporation tubes. And what are the reasons? Insufficient deaeration of feedwater. If we will not properly apply the deaeration, dissolved gases will come into the water and start corroding the lines. Lowering of boiler water and condensate pH, because at low pH it's become acidic and it will affect the piping, metal piping. So we have to operate this with the water around 8 to 10 or 8 to 9 pH depending upon the type of material. Iron contamination of feed water from condensate line, that water contamination iron contamination comes from the condensate line, it start depositing on the boiler with the attachment of this silicate or any other impurities. And ingress of oxygen to boiler during the idle time. When the plant was in outage or in shutdown state, when open the lines, then oxygen ingress in the system and it stay there, and when we start the plant or you can say start the plant again, then this dissolved oxygen starts damaging the system. And third one is carryover problem. Carryover is this is a typical problem which occurs in the boiler when the water convert into the steam. So this is a unique phenomena taking place here. So carryover is a process that results in impure steam quality. We required a pure quality of steam, but if there is a carryover is going on, then the quality of steam downgraded. So what is basically carryover? Sometimes the solid present in the boiler water transfer into the steam due to many reasons. Because there are some impurities, or you can say some dissolved solids are present in the boiler water, but when this water converted into steam, sometimes it takes these dissolved solids due to some reason, and then those dissolved solids now come into the steam, and that steam carries these, and then it will create a problem. This is called carryover. So carryover problems are caused by misting, foaming, priming, and silica carryover. These are the problems which are the carryover problem is caused due to these reasons. And dissolved solids contained in the carryover material can contribute to corrosion and deposition problem in the next stage, that is, it starts in the turbine stage. So troubles in operation due to carryover are reduction in steam purity, and reduction of turbine efficiency due to silicate scale. So these are the major troubles occurred when their carryover took place. And what are the reasons for this? Very important is the rapid fluctuation of boiler operation load. That is, sometimes we operate the boiler at low load, then increase, then middle, or it is fluctuating continuously. This will contribute in the production of carryover. And boiler water contamination like chloride and silica, if there is a high quantity of chloride, silica, and these sort of contamination are present in boiler water, this will also lead to the carryover, and we have to avoid this thing. These are some basic problems. We summarize these issues in this video, and maybe later on we will describe each section separately to describe these phenomena. Thank you very much, and see you in the next coming video, which is